Hello, good day. I came here just to show you how advanced machining, CATIA. So here we have our product. This is this is my car model. I just say it's my car. You can develop by your own, or you can have from any such kind of products, all right, from customers or from any source. You can have models anyways. So here when we talk about advanced machining, as you can see, the model, the features are there are curved surfaces. This is a curved surface where the profile contouring also there. So we have also these pocketing operations, right? By having this product, we are going to see the whole processes, how to generate the NC code in order to do the machining. So here, the first thing we need to do is the CATIA part documentation or part preparation. So here, when you prepare the part, what we need is we really need to study about this product, the size, especially the size. So having this size, we need to choose, we need to prepare the block, the stock from which we can produce this product. So knowing this, we need to produce the stock. So here, from here, we just go as we do it always. So this is the stock. Just right click and go to properties, and then you see you just say it's stock here. Stock, the name is our stock. So we need to produce a stock, develop the model. So you just click on this surface and you go to sketch, right? So you just can have it here. Again, so we can have the part, create such stock. Okay, so the base, uh, you can have such thing. This is the base. So having this base size, you can approximate. It depends on what stock you have, but I just chose this size so that this part, the actual part, is at the middle, at the center. Okay. So as I skip or I just skip the sketch workbench and go to the modeling window. So I just reverse this one. So I can have, you see, so depending how long is this one, all right, how long is this block, our model, depends, the size. The size is depending, we develop the size depending on the size of the part we have. So I make it like 1.2. However, I can reduce it to 1.2. Anyway, that's okay. I think it's okay. So we are going to remove all this so that we do get some roughing operation. Okay, so having this, just okay. So this is a block from which I'm going to produce my part. Let's make it transparent. Just right click here. I go to properties and you can go to graphics. You can make it like this, and the transparency, you can make it around here. Okay, so you can see here, you can see our part is inside the stock. After this, what we do is we need to have the reference. On this, select the reference selection. This is our reference, so it's going to be 0.25 up on the top surface. Okay, so we have, so this is a material preparation process. After this, what we have to do is we go to start and go to machining. So here we have seen prismatic machining. All right, Now we are going to use this, we are going to apply this workbench, advanced machining, CATIA advanced machining. So here in this CATIA advanced machining workbench, what we have is a very important thing, of course, is this PPR. This is a design tree, the machining process tree, we can call it. So we have the P process, the P, the second P product, and the R resource here. So everything we do, every activity in this machining operation or machining activity or the process planning activity, whatever we do, whatever we plan is going to be stored inside here. The operations will be inside this manufacturing program, and the products will be inside, and the resources will be in the resource list. The toolkit we use, machine, the CNC machine we use, going to be stored here. The importance of this is we can redo or we can edit all our process, our plan. Okay, so you have also these operations. You see these machining operations here. So here we have different types of operations. So what makes it different than the prismatic is that we have this roughing and sweeping operations. I think those are the two operations. Yeah, there are a lot of other operations, advanced operations that we see in this advanced machining workbench. So the first thing we need to do is actually we need to prepare. We need to make a database, or we need to prepare the machine we need to use, reference plane, and all these things. We need to do some setup, operational setup. Now, so how we do is that we go to operation here. As you can see on the, you click on this operation. I mean, you can double click here, of course. So if you double click, you have this interactive window. In this interactive window, you can see this, you need to choose the type of machine you need to use. So here, if you click this icon, you can see database of different types of machine we may use. So here, this one is 3-axis, this one is the 3-axis with a rotary table. One is a 5-axis machine. So depending on what we have in our laboratory or in our workshop, we just choose the type of machine. So in our case, we choose this 3-axis machine. So for this 3-axis machine, you have the spindle position. As you can see, the home position is 3.9 something up there, and the tooling you have, and then the compensation, the numerical. So basically is a numerical control. We need to define what the machine's numerical control parameters. So controller emulator we have here. You can use either of this, and the post processor, depending on the post processor you use in the lab. So you may use FANUC. We just use a FANUC here. The post processor word table, yeah, you can use ICAM in table. All right. So it depends what post processor you use. So the NC code, basically we're going to use the ISO or APT ISO. Yeah, this one is no problem. All right. So, it may be APT or whatever. Right. Okay. So having this, just okay. Ring here. So the next one is machine axis, the reference. Right, this is a reference, the machining reference. So our reference basically you just click it here, you see. So you just, I mean, this one center, and then I click it here. So you can see it's green, so you can see every measurement or any tool movement of the CNC machine or the 3-axis CNC machine is X is along here, Y is along here, right? Y is along here. This is just the setup of your CNC milling machine table. Okay, just click. The other one is you need to, register, or you need to identify the model, the actual model for the part design. So here you just click here, and this one is covered here. So maybe if you, yeah, we can use different techniques to identify the inside part. However, you can use as well on this design manager tree. You just can double click here, so you can see here the car model here. On the stock, you can use stock here, double click. Okay, you can use stock here, and we have the reference plane here. Okay, so we define everything, so we just say it. Okay, so we already did the part operation setup. After the part operation setup, what we are going to do is we just start directly the machining, right? So the first thing we need to do, as I have said before, is let me hide the stock. No, just let me hide the stock. So I hide the stock. So the first thing is the roughing operation. You see, you need to roughly produce this part, or bring the shape to this kind of profile. Then nearly almost same. Or yeah, we need to approximate. So we need to use the roughing operation. And next, we need to do some profile contouring around here. You see, profile contouring we need to do. This is a profile contouring, as you can see. What is it? Yeah, this is a profile contouring, as you can see. Next, we need to make it smooth. Maybe due to the roughing, there may be like rough surfaces, so we need to smooth it, to sweep, right? You need to sweep it, right? And finally, we need to do some pocketings, right? We can see this pocket, and we just do the drilling operation here. We drill it. Okay, just to start, so in order to start the roughing operation, actually, the operation has going to be stored inside this manufacturing program. All the programs, processes are stored here. So we need to click it here, and then we go to roughing operation. So the roughing operation interactive window is here. So here, for the roughing operation, we need to key in, or we need to identify the model, the different parts of the model. Okay, so here the red one, it basically is this red part is very important. So you just click here, just identify. This is the futures. You need to identify the futures, different future we have here. So you just click here. So you just click this model. This one. Just click here. You just double click, and then you can see this one is green. The other important is the bottom. The bottom is here. Yeah, the bottom is here. You can see. Well, these are the two important features we need to identify. However, for more enhancement or more refinement, you can add all these features, like this. For example, the rough stock. Maybe is rough stock is stock, right? So you can double click here. Yeah. So rough stock, safety plane. You see the safety plane maybe here, right? So the top is maybe, it starts from, if we show the stock, maybe it includes this one. Okay, also we may do this. More importantly, these two are very important. After doing this, what we do is machining strategy. We need to look in the machining strategy here. As you can see, how should it be? Helical, you know, helical machining strategy. We do have different types of strategies actually. You can use different, you can check, you can do some experiments. So if we use spiral, you know, you can use spiral for roughing as well. The machining tolerance instead of 0.004, let's make it so tight. And radial is, you go this way, you know, the way how you go radially, you know, radially. So we may use step over ratio to step over ratio here. Maybe we use 50% or 40. And actually how we move the tool cutter is we use a maximum depth of cut. How much is the maximum depth of cut? Maybe 0.1 depth of cut is too big. 0.1 depth of cut is too big for, so we may refine it later. Okay, so if you want to understand what is the depth of cut, you just click this question mark. You can see this is the depth of cut, how much you need to go down, right? So you just click it and then you can for the radial as well. So the radial, you see how you go radially, right? More understand what are each of the instructions. After these two, we go to tool cutter. We need to find the tool cutter, the roughing tool cutter. Basically, for roughing tool cutter, we use end mill. So in this end mill, as you can see, we may use, depends on the profiles you have. So most of, let's choose 0.5 diameter 0.5 end. So here, this end mill, yeah, you can see here, this one is editable. You can edit all the tool cutters, you can see, or if you click this more, you can see the different parameters of your tool cutter. So in my case, let me change this one, the nominal diameter. The nominal diameter, I want to make it 0.5. Corner radius, I don't want this corner radius. I'm going to use flat in, like, yeah, you deselect this whole in two. I'm going to make it flat, all right, flat in. So 0. And overall lengths, as you can see, overall lengths, like, standard is 4. Cutting lengths, maybe 2, right, this is cutting lengths. And cutting lengths, overall lengths, cutting lengths, and lengths. Yeah. So yeah, these lengths, maybe I don't know. Let it be like this. I think, yeah. We can see our tool cutter like this. Okay, 0.5. We can have this our tool cutter. When you go to this technology, the flute, they make it two flute. You can check with the high number of tool cutter, the surface, the good the surface, of course. So let's make two number of flute tool cutter. So you have here, you can see here, we choose a tool cutter, and then next is the tool movement, the speed of the tool movement. So here you can change, this is automatic, of course, you can change to whatever you want. It depends on the specification. It depends on the tool diameter and the material. So those approach speed, of course, the approach speed should be lower. Okay, machining is okay, retract, okay, when you retract 1000, yeah, it depends on you. So spindle speed, as you can see, let me make it like 1000 faster. So you can choose, you can do the setup. After having that, the last one is the macro management. The macro management helps you to set up how the toolcutter should approach the workpiece, the movement relative to the workpiece, so that you avoid any collision between the toolcutter and workpiece. Example. So in the automatic here, what you do is you need to optimize retract, okay? You need to optimize, and then here the mode is helical. Let's make it helix, yeah. These are different modes of approach. Okay, so on the pre-motions, if it's not active, you need to make it active. You right click and you need to make it active in your, if it's not active in your case. So you can make it the pre-motion. Here I can make it axial, you see. So maybe I can make it the distance 0.25. And for the posts, this one also I can make it axial and 0.25. So already set up all the for the roughing operations, as you can see. So let me see how does it look like here. So you can see here, these are the tool movements. If you click here, so you can see this is a rough operation we did. It's the tool depth is 0.1, is too much. So you can just set it up, right? So yeah, during sweeping, yeah, it may be. So here, when you do, in this post processing, I mean this macro management, you can set up, you can delete what is or whatever you want, you can set up. Just to show you, you can delete it, as you can see, so you can build it. Okay, so 0.25. Okay, so this is one thing we need to do. The other one is, as I have said, depth of cut. Maybe we can go 0.0. Okay, yeah, because you can see it's too rough here. So you can see it has refined very well. So let me see. So you can see here, yeah, it's good. It's good here. We have 0.05. So the next sweeping operation will be easy. All right. Okay, I think this one is okay. So we just said okay. So after we say okay, if you look into the design tree, you can, if you expand this, you can see this roughing is computed, right? Computed. All the toolpaths are generated. That means computing. You need to make sure that this is computed. That means toolpaths are generated. So after roughing, the next operation is profile contouring, right? So let me just, I think we may just hide this stock, okay? So just hide this stock so we can have this the product. We can see the product, okay? So after roughing, as I have said, you need to highlight this roughing. So the next operation is profile, the profile contouring. So here in the profile contouring, here the profile contouring is coming next to it. So here in the part, what you see is we can to profile contour to machine it all around here. All right, the side, the contour part. So here, as you can see, the outside part is open. This is open or soft. We call it soft. Here on this, in this point, we change it to soft. You see, it becomes soft. So there is no any. This is open space. So just click. We change it to soft, and then we just click. We just show this is the bottom. we need to show the bottom of this, right? This is the bottom, as you can see, right? So the path is also already seen. You see the path is already automatically adjusted, right? After that, there is no need to do. Yeah, you may go the top, or you may look for, we don't have any top plane to show here, or you can use the stock, but the stock is already rough, already machined, so you can use it just for refinement. And regarding the machining strategy, machining style, you can go zigzag or helix. Yeah, you can go helix, or one way, you can go one way, or you can go zigzag. You go here and then you go here. So one way, you just go, all right? Yes, you can do helix, you can do helix, okay? Okay, so okay, and this climb, the direction cut, machining tolerance, yeah, is just as before. Yes, so you can see here regarding the step over here. Step over means the distance between the tool paths. So here it should be a sequencing is radial first. We need to go radially first, okay, not axial first. Axial means we go down, next down. So it's just radial first. Just that one is a good one. I chose that one. You can distance between passes. Well, distance between passes, it depends. If we overhang, also distance between passes, maybe, if we say is 50% overlap, maybe the tool diameter is 0.5. So the distance between, if we say 50% over strip over, and then it can be like 2.5, 0.25. Number of passes just one time. So the overhang, just overhang is 50% in, 50% out. So the axial strategy, when you go down, we need to give the depth of cut here. Depth of cut here, 0.05. We chose 0.05. Regarding the tool cutter, I think the tool cutter is the same. Yeah, same tool cutter we need to use. We don't need to touch it as it is. We don't need to do any tool change, right? Then regarding the feed rate and all this will be the same as well. It's all the one we use, previous one will be coming pop up the same. Finally, the toolpath this macro management. Okay, so the approach distance we need to set. How does the tool cutter should approach the workpiece is one of the issues. So you can use this one, it can be like this, right? It can be circular, it can come like this. Yeah, depending on the sensitivity of the part. Just it should come and touch it slowly, some kind of profile. So you can build by yourself, all right? You can just click none, and then you can build by yourself, all right? You can build by yourself. As you can see, these are the different yeah, you can build by yourself, all right? This is agile. You can draw, you can do it by yourself. You can use axial like this, right? Or horizontal axial. You can use this one. You can, yeah, if you really, you can change this one. Or for example, I may use this 5 here, also 0.25. So I can use this one. Retract also, it may be because here retract. So when it retracts, it may go up straight up, or it should be going like horizontally here and go up horizontally. Yeah, that will be the best one. We can use this one. All right, it goes here and it goes up. That is the safest way. So the clearance, yeah, just safety. So retract will be like, yeah, like what I did for approach. You can set up 5. You can make your own, you can design your own, but in my case, yeah, I can do the same. Okay, now we just finish all the things, and then we can see how it's going to be, right? So from the bottom, you see, yeah, how it approaches already clear. So we have here, and it is approaches, right? So let's go here. Yeah, this one is all right. So yeah, it's already, we already make the profile. You see, uh, the contouring already done. All right. Okay, so here you can in the approach, you can make it this one, maybe higher, or 1.5, for example. If you went with 1.5, you see, yeah, you can see, you can make it, yeah, you can make it from here. This one is the 1.5 I make it. So the, yeah, you can if, yeah, so you can have it because the approach is from the horizontal side. So you can change it different way. Okay, so this one 0.25, so yes, so if we are okay with that, we just okay here. You can see it's okay. So is the contouring operation is already here, right? So next to contouring operation, yeah, see here, you can double click here, and then we can see it as well. This is a contouring operation, all this. So if we just like just to show you on here, as you can see is already computed. So what you see is machining time. You can read here, machining time is here, the total time is here, so how much time it takes. Okay, so we just set it okay, right? Set it okay. So next to profile contouring, what we are going to do is sweeping. You need to make this surface smooth at this one, right? So next to profile contouring, we have here sweeping operation. So this is the interactive window for sweeping operation. So the thing is just here, this is a body part. So we just click on this curved surface. All right, on this curved surface, just click here. Sorry, yeah, we just click here, so it becomes green. And bottom, as you can see, yeah, we just can do the bottom one. This is the bottom one. So sorry, so the other are just additional, right? So we don't need that one. Okay, if you give this, and then next will be the machining strategy, how you do the the sweeping operation, you can do it. This is a zigzag. You can see you can go like you make zigzag, you know, or you can one way next. We can do one way same and all this. So we just choose zigzag, right? So the radial, you can see radial step over is constant. All right, step over is constant. Yeah, it's 50%. Okay. So the distance between passes, yeah, is the distance between passes is too, oh, this one is too small. So the distance between passes between this is, because we are using the end mill before. So what should be the distance between passes? This one is too small. So I think the distance between two passes, I think we can use 0.25. I think that's fair. Okay. This one should be fair. Here, yeah, I think, yeah, that's all. Yeah, what else? Anyone? I don't think we do any other. So the others will be the same, right? Same, uh, yeah. So the tool cutter, next is the tool cutter. As you can see, I think nothing to add on. We will change this one, and we'll see. So regarding the tool cutter, I think we need to change, even though this is 0.5 and this one is for profile contouring. Profile contouring, profile. We just, I can, yeah, just you can name it any, just to name. So here, what we need to do is in profile contouring, I think you need to, I think you just click here so that you activate, so you can activate this. So here we need to use bold email, right? So it should be bold email. Maybe let's make it the same specification. You can see here 0 0.5, 0.5, you go here, you need to set up, just 0.5 here, corner radius is overall length for cutting length is cutting length maybe 2, the length for, yeah, body diameter, yeah, yeah, here is a ball end mill, so it has a 0.25. Okay, so regarding the this macro management, you have approach distance here. For here, how should we approach is the question here. How should we approach? Okay, so it depends on you how you want to approach. All right, so here how we are going to approach is, if you don't have, this one is not active, you can you can do it. All right, so what you do is you just go in and you can build by yourself. You just go and, what is that, build by user. So here in my case I do a horizontal and make it vertical. So I'm designing like this. So in my case, okay, let me just do points, let me just make it point to 0.5. I will see if there is any collision. I will check that, right? The retract also is going to be the same. So and then I have myself. I can use the already the built-in passes so as well. So I make it horizontal and vertical. It will retract like this. Yeah, it's good. It's 0.5 maybe. I mean, it's okay. Use this one. Okay, we have here, right? So we finish the retract, the clearance, and all these things should be optimized. Okay. So finally, we do the setup. Yes, we already finished this one, and this one also we already finished. I think the toolkit. What is the yeah tool number 2, right? The yeah okay. This one I think we can proceed. We can see we can see how is going to be oh, the distance between the two paths is too far away. I mean, it's too rough. So let's see what happens to our workpiece. All right, so we can see here. Oh yeah, it's too rough. As you can see, it's too rough. So the distance between the paths is too far away, and we couldn't find the workpiece. All right, I mean the good shape. I mean the good reference is too high. So what is here is that the maximum between passes maybe 0.05. Yeah, let's check this one. The distance between passes. Oh, the distance between pass is yeah. I think I okay. So yeah, you can see he is very fine here. So if I click here, let me check on this. Okay. Right. So here, let me see. Right. Yeah, it's good. The reference seems good. But yeah, I need to investigate this further. Right. So maybe it costs a lot if you like 0.01, for example. I don't know. If you take it 0.01, so you will see. Uh, see here it's competing, so it takes a lot of time. Okay. So yeah, 0.1 machining tolerance, 0.001. Radial is here, maximum distance passes, right? Radial passes radially. Actually, the number of labels, number of oh, so this is just depth of cut. So maximum depth of cut, I think 0.021 depth of cut. Yeah, if we do that one as well, it's different. So you can change it, even though it's very costly. As you can see, it's costly. maybe the tool cutter, maybe we can reduce the size of the sweeping is, yeah, it's too big. The tool cutter is too big here, so we may change the tool cutter. Tool cutter, maybe, yeah, we may change. Yeah, it may improve. If you use big tool cutter, no, it may not be giving us a good profile. So 0.25 nominal diameter corner, links may be same. 5 here, yeah, we can use. So the nominal diameter, body diameter, same inch. The length, yeah, the length, inch, yeah, it's the same. So we use this one, right? Let's see how it happens. Already calculated, so the time it takes is 20. It's too much. All right, so this is the profile, I mean the sweeping, right? So you can see here, we can see, yeah. So you can do a lot of experiments, especially how the tool cutter is approaching is a very important thing. Okay, so yeah, I can see, yeah, yeah, you can do the experiments, so I can see such things. Maybe the way the tool cutter is approaching is not good. So yeah, is anyway, this is good for our demonstration. This is good. So by this we just say okay. So here, as you can see, the sweeping is calculated, computed. So after sweeping, what we are going to do is we do this pocket. So just go to pocketing. So let me just be fast here. So this pocketing, as you can see, this pocket is actually a closed one. So we need to make this closed. Open pocket, it should be closed. So the bottom part is here. You see, this is the bottom part. So this is the bottom part, as you can see. This is the bottom. What we see here is profile, as you can see. So we don't need this one. Remove all islands. We are not going to make any profile here. No island here. So regarding this path, let's follow this path, the upper path. So just remove this one. So it's important, as you can see, it's red. So it's important. Just click here. Just follow this path. I just follow this path, right? For the for the pocketing. All right. After doing this, I just double click outside here. So it's green. After having this the type of strategy, the toolpath strategy, you can do experiments. You need to do different experiments, so that you can see which one is the best in terms of time, machining time. In terms of the surface finish, you really need to do some experiments. So you can use inward or you can use outward. Basically, I use either of the one. So machining tolerance 0.00. So you see, so this is radially. Step over ratio, I think, yeah, it's 50, as I have said before. Actually, depth of cuts, how will you do the depth of cut? 0.05, 0.01, yeah, 0.0 inch, okay, 0.01, I'm not sure. Let's see this one, okay. Finishing mode is, yeah, need to side finish last level, finish bottom only, side finish at each level at bottom. Yeah, zero zero and so on. Yeah, you can follow. Okay, so you can set up all this number of side finish pass by level. So you can check this one. So here the finishing is this one. So this is the total. So this one you can make this one 0, right? Okay, so this one maybe 0.1, 0.01. All right. So yes. Okay, between one. Okay. Yeah. All right. So this is part. So we can change side finish last level. Okay. I think we need to do a experiment on this. So just yeah. So here we already finished this one. The toolcut. You can choose this one, but it should be like this one is yeah, end mill. Of course this is end mill, as you can see. So we can use 0.5. I think this one, the previous one, you can use 0.25. I'm not sure about this, but depending on the profile you can have this one point, what is that, the size is, how much is it, 0.3, maybe 0.25. I think we can use, yeah. So here we can, this one is I think, yeah, let's use a 0.25 one, 0.25. Lengths for, okay, cutting lengths to, and for body diameter 0.5. Five, yeah. So we have here. So this one is 0.25, 0.25 pockets, pocket one. All right. Okay, after having this, we go to this. I think we can do it as it is. It's automatic. So approach, yeah. So we can approach vertically. So we can do it. We can do it. We can build by ourselves. So approach. So vertically, actually, so it's, yeah, problem. You can use this one, I think, for retract as well. So retract. So you can, yeah, gel. Yeah, you can use this one. So let's see. So the clearance is as it is. So let's see. So you can see here the tool paths. I think, yeah, it's okay. Oh, so I think, yeah, it seems okay. You can see it's computing, right? So here, if you run it, if you, we can do the sweeping. Yeah, it should be fast. Yeah. Oh, okay. Yeah, here need to be careful. I think we need to, maybe the depth of cut should be as minimum as possible. Yeah, I think that the one we select is okay. I think maybe during graphing we need to at least reduce it, right? At least reduce it. So you can see here, just create this one. Just create all this part. Okay, so you can see here it's already, I think it's already okay, right? So if you see here, it's already computed Oh yeah, it took a lot of hours, 4 hours. Yeah, okay. Yeah, it's adding up all the time we are taking. All right, so here we just say okay. All right, so I think so. Here, okay. So the next one is for this one pocketing again. Where is after this pocket another pocket, right? So we use the same tool cutter, I hope. So this one is same time is yeah, is closed as we said. This one is the bottom one, so almost, yeah, this is already we can pocket. We need to use the same tool cutter. This one also same. This one also same. So let's check with that. Yeah, let's check with that. Yeah, okay, so we can have here, right? So all right, so okay, all right, so it seems okay again. All right, so we did pocketing here. So already completed. Next to pocketing, you need to do drilling. Before you do drilling, you need to spot drill. So in order to do that, we have the spot drill we have here on this tab and button. You have spot drilling. You just click the spot drilling here. Oh, this is the interactive window for spot drilling, as you can see. So we need to start from the top. Is from this top is, I mean, yeah, we need to have, you see, this is the top. So that the ones we're going to drill is this one and this one, as you can see. Just double click outside. What about the depths? All right, so the depths maybe 0.1. Let's do that. All right, so we did that. And regarding this tool movement, the tool cutter movement, so the A, the clearance, I think the clearance, the approach distance, the approach clearance distance, as you can see here, it should be like, it should be out. I'm not sure this depths, the depths. You need to check the model, how much depths it should go outside the clearance A. Maybe it should go from this bottom. Yeah, it should go up. Like we can give 0.5, 0.05. I think it should go. I think it should go up. Let's see with this one. Let's do some experiments. I think. Yeah, let's do. Let's see this one. Let's take as it is. We already managed this one. The tool cutter. Regarding tool cutter, as you can see, we're going to have the spot drill, right? This is a what? This is a center drill. This is a spot drill. Okay, so I just activated it. So spot drill, what size of spot drill you need to have depends on this size, right? On this size. Maybe let's check what spot drill we need to have. This is 0.5. Let's make it 0.25. Yeah, 0.25. Overall length maybe 4, right? This one length 2, so body 0.25. Yeah, this degree. All right, this degree. So meet. Yeah, yeah. Okay, so spot drill. I mean spot drill. This one, the approach, yeah, the approach is, oh yeah, like just exactly with a drill approach, and retract also should be. Okay, let's see what's happening here. Yeah, so she's approach distance is within the hole. So let's see, uh, we really need to check that. Yeah, okay. All right, so here what is important is, yeah, so we did roughing, we did contouring, sweeping, pockets operation, two pocket operations, tap drill, and we did drilling. So already the tab is already, the spot is already made, right? Already spot is there. Okay, so yeah, so we can see here, I think, yeah, if it is okay. So what we can see is just okay, right? Just okay. So here in the spot drilling, you already make the spot drilling, right? So we don't need to have you can adjust the speeds and all these things. You can do it by yourself. You can, depending practically, you need to calculate the exact uh, the exact distance or the exact approach. So, and lastly, from the spot drill, we need to do drilling. Yeah, what is a drilling? Yeah, this is a, yeah, this is a drilling, right? You can see here. This is a drilling interactive window. You can see here. So from the top, we need to start from here. Just double click outside, and I think, yeah, these are the drills here. Just double click outside again. What about the depths? You see the depths here. You just click here, and then I think, yeah, I can, yeah, I can, yeah. So you can zoom it here. So you can give the depths. Okay, so this is the depth, so it's going to be 0.5. Yeah, says that. So here our model here is not, it doesn't have like this angle. So what you need to do is we really need to, our drill should not be like that. So here after this we do this profile. After we do those profile, the patterns, here we can go here. So the approach clearance, the clearance here, how much should it be from the bottom? Okay, we really need to look into it. So because if it is smaller, you can see some clashes or some I mean some collision between the workpiece and tool cutter. Let's go to this tool cutter. The tool cutter, basically we are going to use the drill okay. So drill, yeah, it's 0.5, 0.5, 0.5. So you need to change the drill, okay. So here 0.25. So the degree, because it's flat, so it's going to be 1. So here is if you Okay, so after having this, this one is a drill. Lastly, oh yeah, this one, yeah, you can put it up, and you can change those. You know, this you can change this one, right? The spindle speed also you can change. Or here, how should be the approach? Is basically is axial, right? So axial retract should be also axial. Okay, I put it as it is. However, I can optimize it. I can do it. I can change it. So finally, let me see. Oh, okay, so I need to retract should be because let me see. Yeah, you can do one by one. I think if you want the only for the specific operation you can do, you can choose a setup and then you can change it. But let's see the whole process. So here what you can see is all right, so okay, so yeah, well then here so yeah, as you can see here, the already the hole is already created. Maybe the retract the approach distance, maybe we can make it like 1. Okay, so 1. Okay, and this here, yeah, complete it again, so it takes this time. You need to see this one. Yeah, you see this one, the retract and all this has changes, so it will be safer. Yeah, you need to be at the middle. You can adjust it. You can set it up, right? You can set it up. So you can see you can make it the retract approach distance. You need to set it up. So sweeping is all the way it goes, all the way the profile. You try to sweep. All right, you see, yeah, the retract distance is far away now. So you can set that. You can just make it optimized. It should not be longer. If it's longer, it takes time, and then your manufacturing cost will be increasing. Okay, so after having this, we already finished all the operations. So we just we said okay. So we finish all our operations. As you can see here, all the operations are stored inside here, all in sequence, right? Graphing, all these are put in sequence, part model, our part model inside. All our tool cutters are stored here. So we have CNC machines, the tool cutters we use, all right? Okay, so after having finally, what we are going to do is we need to generate the NC code, right? So we need to generate the NC code. So what we do is here in the manufacturing program, this part, just right click here. We just go here's a manufacturing program object here, so generate NC codes. So here, as you can see the NC data type is actually this NC code. All right, so we are going to produce the NC code, and you can see here, so it's active. So for those of you you need to the output file which you need to put, you need to select, right? So this is the default part. So in my case, I'm going to put it in here, CATIA machining. I already created the folder NC code, so I'm going to put it inside, right? So my case is in this folder. Okay, I'm going to put it here, right? So save, all right? So just save it. So the program, the NC part program, the NC code is going to be stored in the file I already selected. I just can click execute. But one thing very important is NC code. You need to, the post processor you need to select, all right? So as I have said, the post processor is just a script code that converts what the toolpaths, the CATIA, the toolpaths of the CATIA generate into something the CNC machine can read it. Okay, so yeah, it generates the code. This is a post processor. It's very important. So for those of you who don't have, you need to have it, or during setting you need to set it up. So after this, yeah, what you need to do is just to generate. You need to, depending on your machine, right? If you have a complete automatic machine, the tool change is automatic, so you can generate the program just as it is whole. Otherwise, if your CNC machine, in our case, for example, is not 100% automatic, we need to change the tool cutter manually. So we may produce by machine operation. Machine operation, each time we need to generate the NC part program. So here you just execute. Just if you click like here, execute, it's executing, it's producing. So the first operation is with this part number or program number. You just say okay, right? Already is producing for the profile. I mean the roughing. For the second one, is sweeping. I mean no, profile contouring. The third one, sweeping, I think. Oh yeah, maybe it's a big data, so it's processing. Yeah, fourth one, all the processes, you know, one by one is generated. Yeah, it's one by one. When it's ending, it will show you success. Yeah, so this is congratulations. So yeah, so it says successful, right? So you just close this one, you go to the NC code. Yeah, here the NC code is always generated, so you can see here the NC code is generated, CATIA NC code. So if you double click here, this is the operation. This is roughing. You see, this is roughing. You see, you have for the roughing operation you can have this one. Okay, so for the others as well you can have, so you can have all the NC codes, so you can see here profile contouring. You see, this is a profile contouring. You can change the tool cutter, you need to change it manually one by one. So you can take all this program using pen drive or anyway. So you can transfer the codes, you can do some adjustments. You may not use the program as it is, so you need to edit this one, because the setup codes may be different from machine to machine. So according to the lab or the workshop procedures you need to follow, you need to ask. So accordingly you need to edit those codes there. By that you can start the machining production in the CNC machine. So with this we wind up our discussion here. So thank you very much. Have a nice day.